All right, welcome back, guys. Today we're going to be doing lesson 8.3.1, How Can I Write an Equation? The first two sections of this chapter involve data. In this section, you will focus on equations. Remember that an equation is two different expressions that are set equal to one another using an equal sign. In lesson 7.3.4, you began solving equations that contain addition or subtraction, such as x plus 18 is equal to 25. You solved these equations using several informal strategies. You also learned how to solve them by undoing with inverse operations. In this section, you will look at another group of equations. This group of equations contains multiplication or division. In this section, you will explore how to solve these equations, starting with writing and solving equations of the form ax is equal to b. So our first core problem for the day is question 84. If you guys read along with me, Margaret is trying to enlarge some diagrams to make several posters for a presentation. She decided on a multiplier of 5. Remember, a multiplier is something that we multiply by, to make the diagrams easier to read from far away. Margaret wonders how much she can enlarge each diagram so that it is the largest it can be while still fitting on the poster paper. The poster paper measures 36 inches by 48 inches. Letter A. Margaret started answering her questions by making the table at the right. She realized that her table would need too many rows before she would find her answer. Help Margaret by writing an expression that represents the width of the enlarged diagram if her original diagram is r inches wide. So remember, this r is a variable, so it's representing the width of her poster. So here's Miss Lanzo. She went ahead and wrote the table on the board for you guys. So again, we're comparing the original dimensions and the enlarged dimensions. So Miss Lanzo, what did you get what expression did you write when you found out that r represents the width of your poster?
So I went back to what we were doing in class a few months ago, and we were looking for that rule. What rule can you get from the original to the enlarged picture? So how do we get from 1 to 5? And I thought, well, we have to multiply. So we multiply by 1 times 5 to get 5, 2 times 5 to get 10, and 3 times 5 to get 15. So it has to be 5 times a number. And what do we use for a number that we don't know, or unknown number? We use a variable. So I'm just going to use x for now. So 5x.
Okay. So you guys maybe at your computers wrote 5r because the book said use r for the inches. Okay, either one though, the variable represents that value, so whichever you guys use is okay. So if we go back now to letter B, so now it says we want to write and solve an equation to determine the widest width that Margaret can use and have it still fit the poster paper if she positions the paper so that it is 36 inches wide. Answer with both a fraction and a decimal. So we already know the expression that Miss Lanzo and you guys wrote, 5x or 5r, is the width. And we know that the largest width we have, the width of our paper, is 36 inches. So we can go ahead and set our original expression equal to the maximum width of our paper. So 5r or 5x is equal to 36. So you guys can go ahead and do it a couple of different ways. So we're going to go ahead and pause the video and see what strategy you guys can use to find out what the width or what r or your variable would represent. And then we'll come back and talk to you guys about a couple of different ways.
Okay, so I'm sure you guys came up with different ideas, but when we looked at the table, we came up with that the enlarged picture had to be 36 inches. So we look at our equation here, 5 times r, or 5 times the unknown number, equals 36. We want to now show you a different way of how to solve this. Instead of just guessing and checking, we're going to do the undo method. Do we have a word for that?
Yeah, the inverse operation. The inverse means that we undo something.
So we want to try to get our variable by itself. And in order to do that, we want to do the inverse operation of multiplication. So our inverse of multiplying is to divide. So if we divide 5 divided by 5 over here, you're left with r. Whatever you do on the one side, you also have to do on your other side. So 36 divided by 5 is 36 over 5 as a fraction, or that equals to 7 and 1/5.
Yeah, so one of the strategies we talked about earlier in the school year was to go ahead and just continue our table, okay? And you see Miss Lanzo wrote 36 in the enlarged column, okay? But it would be pretty difficult for us to use the values we have to get to 36. You know, if we were getting to a number like 35, we probably could use 2 of these and one of our 5s to get to 35. But it would take a little bit more challenge to get to 36. So we go back to the rules we learned a couple of chapters ago, the inverse operation, and back then we did addition and subtraction. So remember, the inverse of adding was to subtract, and the inverse of subtracting was to add. So now we're getting into multiplication and division. So the last thing I asked you guys to do here was to go ahead and write that as a decimal. So 7 and 1/5 is still 7 wholes, and what's the decimal equivalent of 1/5? 2/10. So 7 and 1/5 is actually equal to 7 and 2/10. And you guys can do that using long division. You guys can use that using equivalent fractions to get 7 and 2/10. So if we go back now, so letter C says, using another equation, what is the longest diagram that Margaret can use and have it still fit the poster paper if she now positions the paper so that it is 48 inches wide, meaning she rotates her paper? Explain how you guys solved the problem. So the 5r, or the 5x, still represents the width of our the width that we're making our poster. Okay? Here we set it equal to 36 inches. So if we had our paper like this, now we're just rotating it this way so that we have the longer side for the width of our poster. So the width 5r is now equal to just our new dimension.
Go ahead and take about 1 minute or 2 minutes to solve this and see what you come up for the variable.
All right, let's check what you guys got with what Miss Lands and I got here at the board. So if we go back to the whiteboard.
We went ahead and did the inverse operation again with the multiplying. So the inverse of multiplication is division. So we did 5 divided by 5, which left us with our variable. And then we did 48 divided by 5, which got us the fraction of 48 over 5. We went ahead and changed that improper fraction
into a mixed number,
which we got 9 3/5. But the question also said that you had to change it into a decimal as well. And we went ahead and divided 48 divided by 5 and got 9 6.
If you're thinking about, how do I go quickly from that fraction to that decimal, remember that 9 3/5 is also equal to 9 6/10. Okay, well now that you know that 6/10 is your fraction, we can easily write that as a decimal, 0.6 or 6/10. All right, so great job in question 84. Let's step it up one notch here. So question 85. Raymond took Margaret's enlarged posters and reduced them by using a multiplier of 1/6. So reducing them means that we're making them smaller, okay, which is why we're multiplying by a fraction that is less than 1. So we're still multiplying by a number, but because it's less than 1, it's going to make it a smaller dimension. So letter A says, make a table that shows the width of Margaret's original diagram and the width that it will be in Raymond's book.
Okay, so now we're going to have to go back and look at his enlarged numbers. So we're going to take 5 and we're going to multiply it by that 1/6 that they were talking about in the introduction up here. So we're taking Margaret's enlarged posters and multiplying each of them by 1/6. So 5 times 1/6 is going to give you 0 83/100.
Or you could have left it as 5/6 as a fraction.
Or 5/6. Then we go back and we do 10 times 1/6, which will give you 10 over 6, or 1 67/100. And then you're going to take 15 times 1/6. You get 15 over 6, or 2 5/10.
So this will be one of those times where if it gives you the option of doing, any number can be represented three ways, a fraction or a decimal. So in this case, for me, it might be easier to leave it as a fraction. Okay, for Miss Lanzo, for some of you guys, it might be easier to go ahead and transfer it into a decimal. So again, that's one of the reasons why we can represent any number, multiple ways. So going back to question B now, it says write an expression. So remember, an expression does not have an equal sign. Okay, it just represents one part of an equation that represents the width of the diagram in Raymond's book if Margaret's original diagram is r inches wide. So remember that r represents an unknown. It could be any number, but it does represent the width of Margaret's original drawing. So why would it be, so what do you think that the expression should be? So go ahead and pause your video, write down what you guys think, and we're going to come back and talk to you guys about it. So if you guys got 1/6 r, okay, you guys are on the right track, but the actual answer to letter B is 5/6 r. So the question asks, how would we represent the width of Raymond's book if Margaret's original diagram is r? So remember, we reduced it to 1/6 of the size, which means that if we take 1/6 away from a whole, what do we have left is our 5/6. So what we're going to have left or remaining is 5/6 of the original width of that book. So letter C now says Raymond's book is only 4 inches wide. Okay, so how can we use this expression that we wrote, okay, now make an equation? So we have to set it equal to something. In this case, the width is going to be equal to 4 inches wide. Write an equation to determine the widest diagram that Margaret can use and still have it fit on Raymond's book. Explain how you know that your equation is correct. So you guys can see here, Miss Lanzo went ahead and rewrote this, the expression 5/6 r, and we set it equal to width, which is the maximum width of the book. So that's letter C. Letter D then says, solve your equation from part C to determine the widest diagram that Margaret can use for Raymond's book. Explain how you solved your equation and be prepared to share your method with the class. So go ahead and pause the video again. Make sure you guys use your knowledge about inverse operations to go ahead and solve for our variable, our unknown, which is r. All right, let's check what you guys got. So remember, we left off the equation 5/6 times our variable is equal to 4. So remember, we want to get r by itself. So this 5/6 that we're multiplying by, we want to get rid of. Okay, one of the ways to get rid of this is to make it equal to 1, because any number times 1 gives you itself back. So what can we multiply? We talked about this right before we actually left school. What can we multiply 5/6 by to get something equal to 1? Well, we take something called the reciprocal. So we can multiply it by 6/5. The reciprocal, remember, is just inverting the numerator and the denominator. Okay. So reason being is 6 times 5 is 30, and 5 times 6 is 30, and 30 over itself is going to give you 1. Okay, and 1 times r is just going to give you r. So if we multiply the left-hand side by 6/5, just like we've been working on, we also have to do to the other side. We're going to go ahead and multiply this side also by 6/5. Okay, so remember we said when we multiply over here, we're going to get 30 is r, which is really just 1r. Okay, and where that's equal to 4 is 4 over 1, so 4 times 6 is 24, and 1 times 5 is 5. So r is really just 4 and 4/5. And as a decimal, that would be 4 and 8/10. So how'd you guys do? If you guys did not get 4 and 8/10, don't worry about it. This is still pretty new to us. We're going to keep working on it. But we're going to go ahead and move on now. So question 86. Carolyn is helping her dad buy screws so that they can lay new wood flooring at the hardware store. Carolyn sees the graph at the right posted on the store wall. So whenever you guys see a graph, something you guys want to make sure you guys always do is look at what we're comparing. So on our x-axis, we are comparing the flooring in square feet, and on the y-axis, we are comparing the number of screws. Okay, so when we look at these parentheses here, remember that's a coordinate point where the 1,000 represents what's on the x-axis, and the 600 represents what's on our y-axis. So letter A says to write an expression for the number of screws that Carolyn needs for any number of square feet of flooring. Use a fraction, not a decimal here, in your expression.
Okay, so how to find our expression. We are looking at 1,000 square feet for every 600 screws. So we want to simplify this. So you start with 600 over 1,000, so the number of screws to the square feet. And you could take off 2 zeros on each to leave you with 6 screws to every 10 square feet. So your expression could be 6 over 10 F, which represents the square feet in flooring. Or you can simplify this even more and get 3/5 F. Either one will work. Either one will get you the correct expression when you're solving.
So some of you guys may have noticed 1,000 over 600 or 10 over 6. And we want to be careful there, because if you go back to the question, it says we want to write an expression for the number of screws needed for any square feet. So it's a ratio where we're comparing the screws to square feet. And you guys may notice here that we went ahead and labeled our XY coordinate pair just so that we know what our X and what our Y represented, because it makes it easier for us to, a little less confusing for us to make mistakes here. So letter B then says, Carolyn already has 250 screws at home. Write and solve an equation to determine how much flooring she can lay with the screws that she already has. If we don't want to go out and buy any, we're all self-quarantined right now, we can't go out and buy more screws, what can we do with the 250 screws that we have at home? So you guys have already written a couple of different expressions. 6/10 times F, we reduced it to 3/5 times F. You could have left it as 600 over 1,000 times F. Just, the smaller the value of the fraction, the easier it is to solve into later on. So how can we use our expression to go ahead and now make an equation?
So for the sake of this, I'm going to use our smallest one, our reduced one. So 3/5 F, and it's going to equal 250 screws at home. So now take a minute and try to solve the equation, I'm sorry.
And what are we solving for? We're solving for the variable. The only thing up there that we don't know is F.
So I went ahead and did the inverse operation again from our previous problem in 85. We know that we can flip or use the inverse fraction. So 3/5 times 5/3 over here would give you 15 over 15, which equals 1. We also have to do the same side on the right-hand side. So 250 screws times 5/3, which will give you 1,250 over 3. Now, you could leave it like that, or you can say that you can have about 417 screws.
And how would you get 417?
I mean square feet, I'm sorry.
You would just divide the 1,250 by 3. So 1,250 divided by 3 is around 417 square feet. All right. So again, guys, this is a little bit new. We're building on some previous knowledge. It's going to take a little bit of time to understand. If you're completely confused, make sure you guys reach out and email Miss Lanzo or myself, and we'll kind of help you guys out as much as possible.
Great job today.
Yeah, great job today, and we will see you tomorrow.